I'm going to work through all of the problems for this test review sheet that we have that covers sections 5.7, 7.5, 8.5, 9.5, and 9.6, and then the chapter 10 sections 10 through 10.2 through 10.5. So let's go ahead and just jump right in, starting with number 1, and you can see the directions there on your sheet. The first two problems tell us to write an equation for parabola with the vertex at the origin and the given focus. So for number 1, they're telling us that the focus is at the point -2, 0. I strongly recommend, if you are having trouble with problems like this, that you just do a little rough sketch. Not required, but I think it helps some people. Just draw a little sketch and plot where -2, 0 is on the coordinate plane. All right, so there we are at -2, 0. And we're told in the instructions that the vertex of this parabola is at the origin. Well, because the focus is always inside the mouth of the parabola, that tells me that this parabola has to open to the left. Okay, so I don't have to get exact, but I'm just giving myself a picture. So here I have this parabola opening to the left, opening over or around, however you want to think about it, the focus. And then we know that for the parabola that opens to the left, the equation form, just using variables, looks like this. Since it opens to the left, I'm going to have the x equals equation, and the a number is going to be negative. All right? So it's just going to be our job to find out the exact number to plug in for a in this equation, and then we'll have our answer. So here's how you find a. You use this formula. I'm going to show you the formula, and then we're actually going to plug in the number that we need for c. All right, just remember that c stands for distance between vertex and focus. That's c, the distance between the vertex and the focus of a parabola. Well, in this case, c is 2. You can obviously see that it's 2 units from the vertex to the focus. So the absolute value of a is going to be 1/4 times 2. And that means that a is going to be 1/8. All right, so to finish off my answer, I'm going to drop 1/8 in place of a in this equation. And my answer is x equals -1/8 y squared. All right, that's the answer for number 1. Number 2. This time they give us a focus in a different place. This is on the y-axis. To be more exact, it's on the positive y-axis, which tells me that this particular parabola has to open upward, because the focus, again, is inside the mouth of the parabola. So I go the next step, and I pick out the equation for the parabola that opens upward. And it's this one. Solve for y, because it opens up, and a is positive, opens up. Okay? Once again, we have the same job. We've got to find out what this number a is and plug it in. So I'm going to use that same formula. Let's show it one more time. Use this formula a lot when you're dealing with parabolas. All right, well, this time my c number, the distance between vertex and focus, is 4 units. All right, so this time in this formula, I'm going to replace c with 4, and I get a of 1/16. Okay, so we're pretty much done. I'm just going to replace the a variable in this equation with 1/16. The final answer is y equals 1/16 x squared. Okay, So that's the first two problems. All right, now, starting with numbers 3 and 4, the directions changed. They're going to give us an equation for a parabola, and it's our job to find the focus and the directrix. Okay, well, for number 3, there's one little issue. So just keep this in mind. Before you can do anything as far as finding focus and directrix or graphing, anything like that, these equations have to be solved for one of the variables. And the one variable that you always solve for is the one that's the lower degree. Okay, in this case, number 3 needs to be solved for x. All right, so my first move is to solve this equation for x. And if it's okay with you, I'm just going to turn this around. I just like to look at my equations this way. I'm going to let the solve for variable be on the left. And the way I solve for x is I just multiply by 1/4, the reciprocal of 4, on both sides of the equation. And that's my quadratic equation now solved for x. Now I can go about the business of finding the focus and the directrix. Well, we're going to use that familiar formula, just like we did on the previous problems, except this time I know what a is, because a is that constant that's in front of the quadratic variable. So in this case, a is 1/4. I'm going to use that to find out what c is. Remember what c represents? C is the distance from the vertex to the focus. Okay, so here we just do a little cross multiplying, let one product equal the other, and you get your c value. So I know that it's 1 unit from the vertex, which by the way is at the origin. I know that by looking at this equation because I don't have any addition or subtraction anywhere in this equation. So my vertex is at the origin, and now I'm going to notice how this parabola opens. Well, it's solved for x, so right away I know that it's got to open either to the left or to the right. Just think about the x-axis. It runs left and right. Okay, so taking it one step further, I notice that the a number is positive. So what that tells me is I have a parabola that opens to the right. And therefore, my focus has to be somewhere on this positive x-axis because it's on the same line as the vertex. And it travels in the same direction, the focus does, as the parabola opens. Well, we already determined that c is 1. So that means I'm going to travel one place to the right of the vertex, and that will indicate where the focus is. And the ordered pair of this point is 1, 0. All right, so I found the focus. Just identify it this way. The focus is the point 1, 0. Now, what do we know about the directrix? Well, it's a line. And it's the same distance away from the vertex, but in the other direction. So I'm going to go left 1, and I need to draw a vertical line. So the way to remember the directrix is if your quadratic equation says x equals, your directrix should say x equals. They should match. And what does x equal? Well, I'm crossing the x-axis at -1. So that's the answer for the directrix. All right, done with number 3. Okay, number 4 is similar in that we don't have a variable solved for, and it looks like I need to solve for y. Y is the lower degree variable. So once again, I'm going to turn this around, and when I do, and I solve for y, I hope you recognize this hopefully very familiar equation form because we've looked at this a lot this year. What I have here is a quadratic equation that is in what is known as vertex form. Okay? Vertex form because it's easy to identify the vertex. The x-coordinate of the vertex comes from inside the parentheses, and this is where it's a little tricky. You really have to think opposite of the way it looks. The y-coordinate of the vertex is this number outside the parentheses all by itself. Okay, so I've got this vertex, which really wasn't required for me to find, but it's nice to know where the vertex is so you can identify the focus, all right, and the directrix. Okay, so here we have this parabola that opens upward. Let's just do a little rough sketch. We're actually going to do the complete graph on the next problem, but maybe just a rough sketch to illustrate the focus and the directrix. So here we are at -2, 4. This parabola opens upward because it's solved for y, so it's got to be up or down, and since a is positive, it's up. Okay, so what that tells me is that somewhere straight up from the vertex will be my focus. Well, how far? Well, that's what C tells me. C in this little formula. If I solve for C, then I'll know exactly how far to go up. Okay, well, we're going to let A be 1/4. This is A, whatever the number is in front of the parentheses, and over 4C. So hopefully you can see that 4C equals 4, so C equals 1. All right, well, that really helps us locate the focus because I'm going to travel up one place. Let me erase all these little dots. Okay, so if I'm here at the vertex at -2, 4, and I travel up one place, then I hope that you can see, let's do it like this. I hope that you can see I'm now at the point -2, 5, and that's the focus. All right, remember that the directrix is also C units away, but in the other direction. And the equation for this line, remember, it's got to be y equals, let's put D for directrix. Hopefully you can see that the equation for that line is y equals 3. Okay, so we went up 1 to get to the focus. Notice how we just added 1 to the y-coordinate of the vertex. And then I went down 1 to get to the directrix. So I just subtracted 1 from the y-coordinate of the vertex. All right, so since all we're asked to do here is identify the focus and the directrix, we did that, and now number 5 is going to ask us to go ahead and sketch the official graph. So let's just make this official. Let's remember the vertex is -2, 4. All right, and we've already found the focus, so that's pretty easy. Here's the focus. Here's the directrix. Okay. And now it's just a matter of doing some inputs and outputs. And I just really need 2 numbers. I like to stay, here's my AOS. Remember the AOS? I'm just going to stay pretty close to the AOS. I'm going to plug in -1 for x. Okay? If I let x be -1, let's see if we can do some mental math here. -1 plus 2 is 1. Okay? 1 squared is still 1. 1 times a fourth is a fourth. And then a fourth plus 4 is 4 and 1/4. So for -1, I'm going to go 1, 2, 3, 4, and then just a little bit more. And because of symmetry, I don't have to calculate this one. Okay, well, my next input is going to be x equals 0. Okay, let's see what we get. 0 plus 2 is 2. 2 squared is 4. 4 times a fourth is 1. And then 1 plus 4 is 5. That's a lot easier to plot. So here's 0, 5, and then symmetry gives me a matching point. So I'm going to use those 5 points. I always want you to use 5 points for parabolas. the vertex counts as one of your points. And so here we are. There's your answer for number 5. Focus, Directrix, the 5 points for the parabola. And you really could have picked any numbers you want. These are independent, and then here are your dependent variable values. All right, let's move along. Here we are writing the equation for a circle. So maybe we should go ahead and just write the standard form using variables for the equation of a circle. Okay, and in this equation form, h and k represent the center. And then if you do the square root of that, meaning r, that will be the radius. All right, so with that in mind, in this case, h is -2, k is +6. So when I put -2 in for h and I subtract, that's going to make positive or plus. Okay? When I put +6 in for k and subtract, I get subtract. The radius is 4, but the equation says radius squared, so 4 squared is 16. So that's my answer for number 6. Okay, let's move on to number 7. Let me change the color up a little bit. Since we're subtracting 0, x minus 0, I'm not going to show x minus 0 because x minus 0 is just x, so I'm just going to show it as x squared plus k in this case is 1. Remember, this is h and this is k. So we got y minus 1 squared equals the radius squared, which is 4. So that's your answer for number 7. It's pretty easy. All right, now number 8, you're still writing the equation for a circle, but this time they don't just come right out and tell you what the radius is. They're going to make you work for it a little bit. So the radius is really the distance between these 2 points. It's the distance really between the center and any point on the circle, because remember, all of those points are the same distance away from the center. So I can find the radius by using the distance formula. So let me just write that out in case you've forgotten. Here is the distance formula. So we're basically going to take the x coordinates from each of these ordered pairs, subtract them. All right, so let's just go ahead and do that. Doesn't really matter how you go about this. I'm going to do 1 minus 0 squared plus, and then I'm going to subtract the y's, -2 minus 1 squared. Okay, and then we'll simplify. 1 minus 0 is 1, and 1 squared is still 1. -2 minus 1 is -3, and -3 squared is 9. Okay, so it looks like the radius is the square root of 10. Okay, so now remember, we're going to use the center. I'll change color in our equation. So we're going to do x minus 1 squared plus y plus 2 squared equals radius squared. Well, this is radius. If you square that, if you take the square root of 10 and square it, you get 10. So this ends up being my final equation. All right, very good. So that's the answer for number 8. All right, now we move to writing the equations for ellipses. And all of these are centered at the origin, so that makes it pretty nice. What do we know? Well, we know that the foci are on the x-axis, so that tells me that x is the major axis. All right? So by knowing the foci, it's 5 units from the center to a focal point. So I'm just going to write variables. That tells me that c is the distance from the center to a focal point, and that distance in this case is 5. Covertices. That distance from the center to a covertex is 2. And the variable that we associate with covertices is the variable b. Well, obviously, the variable that we need to write the equation for the ellipse is a. And then move on from there to get a squared. Well, for ellipses, the way you find the variable that you're looking for is you use c squared equals a squared minus b squared. All right, so since c is 5, that makes c squared 25. A squared is what we're trying to find, and b squared is 4. So it looks like a squared is 29. Okay, so now let's move on to writing our equation. For ellipses, these numerators do not change ever. They're fixed. We will position the denominators to indicate which axis, either x or y, is major. The one that's major gets a squared. A squared is always the bigger denominator. Well, we've already indicated that x is the major axis, so x squared is going to get a squared, meaning y squared is going to get the smaller denominator, 4, or b squared. So that's my answer for number 9. Okay, number 10. Well, this time they give the information, a little different information. They give us the location of a vertex. Remember, we're always on this, at least at this point, we're centered at the origin. So the distance from the origin to a vertex is 10 units. And that vertex, or that distance, is always indicated by the letter A. A is 10. The distance from the center to a covertex is 7 units. And remember, covertices are indicated by the variable B. Well, this one's going to be kind of easy because we just need to realize which axis is major. All right, so we can go ahead and set up the ellipse equation with the numerators because they don't ever change. But we need to ask ourselves the question, which is the major axis? Is it the x or is it the y? Well, the vertices will tell you that answer because vertices represent points on the major axis that the graph crosses. So by showing you that the vertex is on the y-axis, they're basically telling you that y is the major axis. Okay? So since a is 10, a squared is 100, and I'm going to put a squared underneath y squared to show that y is major. That means b squared is going to go underneath x squared, and b squared, which is 7 squared is 49. Okay, so that's my answer for number 10. Okay, well, now we're given the information just a little differently. We're given the dimensions. And once again, it's no problem if you just want to draw yourself a little sketch. If your ellipse is a total of 14 inches wide and it's centered at the origin, that means that 7 inches have to be on either side of the origin on the x-axis. If it's a total of 8 inches high, going this way, that means that 4 inches will be on either side of the origin on the y-axis. So, which axis is major? Well, it's pretty obvious that the x-axis is major. Okay, so when I set this up, since x is major, I'm going to put a squared underneath x squared, which is the bigger denominator. B squared will go underneath y squared. Okay, well, the distance from the center to a vertex, this distance we call A, and A is 7. The distance from the center to a covertex we call B, and B is 4. All right, so that makes it pretty plain. I'm going to put 7 squared underneath x squared. It's 49. And I'm going to put 4 squared underneath y squared. 4 squared is 16. And that's my answer for number 11. Okay, so that takes care of the front page. And now we're going to do 4 graphs. All right, so let's run through these graphs very quickly. Now it's going to be your job to understand by the equation that you're given whether or not you're graphing an ellipse or a hyperbola. Okay, so these first two are both ellipses because you'll notice they have plus in the equation. Okay, so the way we graph these is it's really pretty simple. Take the square root of 36, 6 and negative 6, and plot those points on the x-axis. 2, 4, 6, 2, 4, 6. Now do the square root of 81, plus and minus, and plot those numbers on the y-axis. 2, 4, 6, 8, 9. 2, 4, 6, 8, 9. And you're going to use those 4 dots, those 4 points, to draw a rough sketch of an oval shape. Whoa, that's just too ugly. I guess we'll live with it. All right, so obviously y is the major axis. A squared is 81, b squared is 36. And so when we find the foci, remember for ellipses, we use this equation to find foci. We're going to place those focal points on the y-axis. Focal points always go on the major axis. Okay, so c squared is 81 minus 36, and that is 45. So we need to find the square root of 45, and we'll round it to the nearest tenth, and that is 6.7. C is 6.7, so it's 6.7 units to a focal point, and there are 2 focal points, 2, 4, 6, here's 7, so it's just shy of 7, positive 7, 2, 4, 6, 7, so it's just shy. And I'll always like for you to show these in ordered pair form. So this is the way we would indicate the foci using ordered pairs, since they have to go on the y-axis. All right, moving right along. Number 13 is another ellipse equation, but the difference here is it's not in standard form. So my first move is to divide everything by 36. Standard form for an ellipse equation has to equal 1. All right, and so now when I divide by 36, I get x squared over 4 plus y squared over 36 equals 1. All right, and so we're ready to graph just like we did before. The square root of 4, 2, negative 2, on the x-axis, the square root of 36, 6, negative 6 on the y-axis. Draw your oval shape. Okay, once again, I gave you another one where y is the major axis. And so we need to find foci. C squared is a squared minus b squared. C squared is 36 minus 4. Okay, so grab your calculator and let's find the square root of 32. We'll round it to the nearest tenth. That's 5.7. C is 5.7. It's 5.7 units from the center to a focal point. So it's almost to 6, just inside 6. Change the color because it's real close. So the way I would show this in ordered pair form is 0 plus minus 5.7. Okay, what do you think? So far so good? Great. All right, let's move right along. On number 14, notice the equations change. Now we have subtraction, and that indicates to us that we're going to be graphing hyperbolas. Well, we start off graphing hyperbolas very much like we did with the ellipses. We do the square root of 9 plus and minus 3 on the y-axis. Just look straight up. And 3 and negative 3 on the y. And then square root of 16 plus minus 4 on the x-axis. Okay, but now it changes because for hyperbolas, these 4 dots will be used to form what is called the interior, or your book uses the term central rectangle. All right, and it's from here, it's this interior rectangle that is used to help us draw asymptote lines. All right, so I'm just going to use my line draw tool here and see if I can, you would just draw these continuously, but it's easier for me to draw them like this. Okay. All right, now with hyperbola equations, it's very important that you recognize which variable, either x or y, comes first in the equation. Because in this case, since y comes first, that's the axis that I'm going to draw through. My curves are going to cross only the y-axis. So I'm going to treat these asymptote lines as I will approach but never touch. I'm going to go through the vertex, which is at the top of my rectangle, approach but never touch. Okay, so there's one of the parabolas, and then I'll do the same thing on this end. Okay, now the only thing left to do is locate and plot the foci. Well, we're going to use the Pythagorean Theorem. Okay, so c squared is a squared, which is 9, plus b squared, which is 16. C squared is 25, so that means c, the distance from the center to a focal point, is 5. So remember, for parabolas, focal points always go inside the mouth of the parabola. So we're going to have a focal point at 0, 5 and at 0, negative 5. So we can show it like this. All right, that takes care of 14. 15, let's see what this one looks like. It's already in standard form for us. It is a hyperbola because it's minus. Okay. So let's build our rectangle. The square root of 64 on the x-axis, 2, 4, 6, 8. 2, 4, 6, 8. The square root of 4 on the y-axis, 2, 2. Use those 4 points to make your rectangle. All right, grab your straight edge and draw your asymptote lines using the rectangle. So you basically just line up the opposite corners and the center. So you're not going to actually draw them like this. It's just easier for me with this Mimeopad. So you're going to make an X. Okay, well this time I noticed that X is in the lead. So these two parabolas are going to be crossing the X-axis. So once again, I use these asymptote lines as guides. I go through that vertex, and I go through this vertex. And the only thing left to do is to plot the foci. Using the Pythagorean Theorem, a squared is 64, b squared is 4, c squared is 68, and let's get our calculator and get the decimal equivalent rounded to the nearest tenth of the square root of 68, and that is 8.2. So we're going to plot on the x-axis 2, 4, 6, 8, and then just a little bit more. Same thing over here, just inside the curve. So we would say plus minus 8.2, 0 to show that they're on the x-axis. Okay, looking good so far. Now let's write some hyperbola equations. These are all centered at the origin. So I'm given the location of the foci, and that's 4 units away from the origin. So my C value is 4. I'm also given the location of vertices. They are 2 units away from the center, which is the origin. So remember, vertices can always be associated with the variable A in my equation. So A is 2. So one other thing I notice is that both of these, actually all 4 of these points, both foci, both vertices of course, they're on the y-axis. So what that tells me is that when I write my equation for this hyperbola, I will begin with y squared then x squared. These denominators never change for hyperbolas. It's always a squared and then b squared. Well, I know what a squared is, because a is 2, a squared is 4. I just don't know yet what to put in for b squared. Well, that's where your Pythagorean theorem comes in handy. So c is 4, c squared is 16. We already said a squared is 4. So it looks like b squared is going to be 12. Okay, well that takes care of that. This other denominator is 12, and that is my answer. So once again, identify where the foci and the vertices are for the hyperbola, either the x or the y-axis, and that will tell you which variable to lead with in your equation. And then you find either a squared, usually you're going to be finding, in this case, you'll always be finding b squared when you're given foci and vertices, and you use the Pythagorean theorem to do that. Well, this one's a little interesting. This time they're giving you the fact that the transverse axis is horizontal. Remember what we learned about the transverse axis. It basically is the line between 2 vertices. All right, and remember, you can think of the center being the origin. Okay, so let me just pretend for a second that this red line represents the horizontal transverse axis. And if it's a total of 6 units, then that means this has to be 3, 0. And this has to be negative 3, 0. Okay, total of 6 units. And the rest of the box should be a total of 4 units. It's a 6 by 4 box, so it's 6 this way and it should be 4 this way, meaning it'll be 2, it should be 0, 2, and 0, negative 2. That makes a total of 4. Okay, you see that? 6 this way, 4 this way. Okay, so what we know is that this hyperbola has to open on the x-axis because the transverse axis is horizontal and the x-axis is horizontal. So that means my A value, the distance from the center to a vertex, is 3. And the other distance from the center to the other side of the rectangle, we call that B. B is 2. Okay, so this is going to be pretty easy to do. Since the transverse axis is horizontal, then x squared will come before y squared. And now it's just a matter of putting a squared as the first denominator. A squared is 9. And b squared, 4. And that's my answer. Not too bad. Okay, now we get into some old stuff, going way back. This is section 5.7. If you want to go back, and you probably don't have that homework anymore unless you kept it from first semester, but you can go back and look at the book. But basically, here's how we change standard form, which is what we have here, into vertex form. All right. It involves completing the square technique. So the first thing I'm going to do, just like I would with completing the square, in the parentheses, I'm going to do the square root of this quadratic term. The square root of x squared, of course, is x. Whatever sign follows will go next. And then remember, when you're completing the square, what you do with this linear coefficient, you always divide it by 2. 4 divided by 2 is 2. Okay. So far, so good. Now, we'll change some color here. What I'm going to do next is I'm going to take this number in the parentheses and square it. 2 squared is 4. And I'm going to come up here to standard form, and I'm just going to subtract that number that I had in the parentheses squared. 2 squared, always subtract. Okay? So now just think about putting those two constants together. If you put -7 minus 4 together, combine them, you would get -11. And that is vertex form. That's all you do. This number squared, you know how we got that number? We divided the linear coefficient by 2. And you just have to practice this. That number squared will be subtracted from this constant every time. It's always subtracted, so you don't have to guess. Okay, well, we got the vertex form. Now what's the vertex? Well, the vertex of this will be -2, -11. And that's the answer for number 18. Number 19, we got to solve this rational exponent. This is a rational equation. Well, it's actually a radical equation. The first thing we have to do is isolate this radical. You might not see it as a radical, but actually, if you were to take just this part of the equation, it's the cube root of x minus 2 squared. So it's really a radical, but it's written using a rational exponent. So this radical needs to be isolated. That means I've got to undo multiplying by 2 first. Okay. Now, I've got to get rid of this rational exponent. And the way I do that, it's pretty easy. I just raise that rational exponent to its reciprocal. I raise this whole side to the reciprocal power. The reciprocal of 2/3 is 3/2. But I can't forget that if I raise the left side of this equation to the 3/2, I also have to raise the right. All right. The effect of this is these exponents cancel each other, and I'm left with x minus 2 on the left side of the equation. Now on the right side, you got to be careful because the radical form of this, remember these rational exponents really represent radicals. This is the square root of 25 cubed. And since this is an even root, this is a 2 in here, even though it's invisible, I've got to include plus minus. Anytime you do an even root on both sides of an equation, which is essentially what we just did, don't forget plus minus. Okay. Well, let's take this a step at a time. We know the square root of 25 is 5, and 5 to the 3rd power is 125. So I'm going to end up with 2 answers. One of my answers will be found by solving x minus 2 is positive 125, and the other one will be found by doing negative. Okay, so my 2 answers end up being 127 and negative 123. All right. Sound good? Okay, moving right along. All right, here we have a variable that is in the exponent. We're actually solving for the exponent. So whenever you see variable, you're trying to solve for a variable that's in an exponent, the first thought I want you to have come to your mind is logarithms. This is why we learn about, it's one of the reasons why we learn about logarithms. It's to solve problems like this where the variable is actually part of my exponent. So to solve this, I'm going to change this equation into a log equation so that I can get my calculator and easily come up with the answer. So I notice that the base is 5. So when I write my log equation, I'm going to write log base 5. I also know that logarithms are basically exponents. They're just another way of showing or finding exponents. So I'm going to let this log expression equal the exponent. Well, that just leaves one other number, so my process of elimination, I know that I'm going to fill in that blank with this number. So here is the log equation that really is just another way of writing this exponential equation. But the good thing about this is I can now use my calculator to get to the answer. Okay, so for this left side, I'm going to use what is known as the change of base formula. And this goes way back, I know, but I just want you to be familiar with it because it's probably going to come in handy for you later on. And it's easy to use. You're going to do log on your calculator of the top number, which is 24, divided by, then you're going to hit the log button again, divided by the base log, in this case it would be log 5. Okay, well, let's go to your calculator and let's make sure we both get the same answer here. So hit the log button, type in 24, close parentheses if you have to, divided by, hit log again, put in 5, enter. And we are rounding to the hundredths. So let's just go ahead and round this number to the hundredths, 1.97. Okay, so log base 5 of 24 rounded using our change of base formula, we came up with 1.97. Now it's really pretty easy to solve for n. We just subtract 1. I've already got that number in my calculator. I'm subtracting 1, and my answer is 0.97. So that is the answer for number 20. Very good. 21. Believe it or not, this is another log problem, and in just a minute I'm going to, hopefully you'll understand why. We're told that we have interest being compounded monthly, so we're using our compound interest formula, not continuous compounding. Remember, that's the PERT formula. This is monthly compounding. And the question basically says if we took $3,000 and it doubled, so in other words it became $6,000 at a given interest rate, compounding monthly, how long did it take? Well, we're going to be much like the previous problem where we're trying to find a variable that's actually part of an exponent. That's exactly what we're doing here. So I want you to think eventually log equation. We just have to get to that point where we can change this into a log equation. Okay, A in this formula represents the ending balance of your investment. Your $3,000 ended up being $6,000. The problem says it doubled. So A in this case is 6,000. P represents the initial investment. Okay, rate is in decimal form 0.0275. N stands for how many times during the year did compounding on your money take place? Well, monthly compounding means it took place 12 times. Okay, well, N, you'll see N again up here in this exponent, but T represents years, and that's what this problem is asking for. How long, how many years did it take for this initial investment to double at this interest rate? All right, so let's get this into a point where we can change it into a log equation, then our calculator will do the work for us. The first thing I'm going to do is just combine all of this in the parentheses. Okay, I'm going to bring the rest of this down. So in your calculator, you need to find out what 1 plus 0.0275 divided by 12 is. Okay, and I'm working on it. And it looks like it's 1.002291667. Double check that. 1.00, just going to go ahead and write that out. 1.002291667 to the 12t power. All right, well, I need to isolate, before I can change this into a log equation, I just want the base and the exponent that I'm going to try to find isolated by itself on this side of the equation. So I need to undo multiplying by 3,000. It should be easy enough. 6,000 divided by 3,000, of course, is 2. All right. And now I've got this isolated. Okay, now think log equation. I've got to find the variable that's part of an exponent, and so to do that I need to change this into a log equation. Well, the base is this long number. Okay, remember logarithms always equal exponents. Okay, so far so good. So now we're going to use that change of base formula again like we used on the previous problem. So we'll just hit the log button and put in 2, it's the top number, divided by log again, and now you're going to enter in that decimal, 1.002291667. And that's 302.81. Equals 12t. 302.81 equals 12t. So that number divided by 12 will get me my answer. So it looks like, and we'll just round it to the nearest year, looks like t is approximately 25 years. And that's my answer for number 21. All right, we're almost there. Hang in there. Number 22. We're adding two fractions that do not have the same denominator. And before I can add two fractions, I have to come up with a common denominator. They have to have the same denominator before they can be added. So the first step in simplifying this is to factor the denominators. And we need the factors of negative 12 that add up to negative 4. That would be x minus 6 and x plus 2. And I'm going to factor the right denominator using GCF, 4 times x plus 2. Okay, well, what is the LCD? Well, the LCD is really just a combination of all of these factors. So it looks like it's 4 times x minus 6 times x plus 2. Maybe we can do a different color. Okay, so I'm going to set this up so that these denominators can divide into the common denominator. Okay, each one of these denominators from my original problem will divide into the common denominator. All right, so I'm dividing red into green, and I notice that everything cancels when I do that except for this 4. And this 4 that doesn't cancel will multiply by 1. 4 times 1 is 4. All right, same thing over here. Dividing red into green, I notice everything cancels except for x minus 6. And x minus 6 now gets multiplied by 3x. So x times 3x is 3x squared. And 3x times negative 6 is negative 18x. Okay, now we can combine like terms in the numerator. 3x squared minus 18x plus 4 over the common denominator of 4 times x minus 6 times x plus 2. And if we could factor this numerator, we would, but there is no way to factor it. There's no GCF, and there are no factors of 12x squared that add up to negative 18x. So this is it. This is my answer for number 22. And we just have one more. All right. For number 23, to solve this, I want to clear fractions. I just want to get rid of these denominators. And the way I'm going to do that is multiply both sides of this equation by the common denominator, which is k plus 1 times k plus 2. K minus 2, sorry. K plus 1 times k minus 2. All right, so I'm going to divide this first denominator into the common, and you'll notice that these would cancel. And the part that doesn't cancel will multiply times k. So k minus 2 times k is k squared minus 2k. All right, let's keep on doing that same thing. when we divide k minus 2 into this common denominator, you'll notice that these cancel. So now I'm going to multiply k plus 1 times k. K squared plus k. Right? Makes sense so far? Okay, on the right side, I'm just going to multiply 2 times this product. So you can either go ahead and do FOIL first and then distribute 2. Okay, I just went ahead and did the FOIL method. And now I'm going to distribute 2 to that, and I get 2k squared minus 2k minus 4. Okay, so far so good. K squared minus 2k plus 1k is minus 1. All right, so now let's work on combining like terms. We can add k squared and k squared. And we can combine these k terms. Negative 2 plus 1 is negative 1k. Okay. No pun intended. The k squares are going to cancel when we subtract. Hopefully you can see that. We can just mark those out. So let's put our k terms on one side of the equation and then leave our constant on the other. So I'm just going to add 2k to both sides. Negative 1 plus 2 is 1, okay. And then we have negative 4. These would cancel. And we have our answer. K is negative 4. Okay, that wraps it up. That wasn't too bad. If you have any questions, make sure you send me an email or come to academic support, and we will see you in class.